Now we'll go to logarithmic, or now we go to exponential equations. Okay, this one is in exponential form right now, and we're looking for the exponent. So I think the easiest way to do this would be change it to log form. So it'll be log base 2 of 7 equals x. How are we going to find a number solution for that? Oh, let's remember the change of base formula. So log base 2 of 7 would be log base 7 divided by log base 2. So we'll say this is our exact solution, and then when we use our calculator find that, we'll find out this is approximately 2 and 807 thousandths. So there's both the exact and the nearest thousandth solution. Well, this one, we have 2 exponential. In this case, what we have to do is we take the log of both sides, and it doesn't matter if you use the common log or the natural log. So I will have the log of base 5 to the 2x minus 3 equals the log of 8 to the x plus 1. Now I use my power rule of exponents, and the 2x minus 3 we pull out in front, and we take that times the log of 5. And we'll have the x plus 1 out in front, and we'll take that times the log of 8. Make sure you use these parentheses. Make sure you do. Now our next thing is to remove those, and we'll have 2x times log 5 minus 3 times log 5. So we're using the distributive property. And distributive property over here, we'll have x times log 8 plus 1 times log 8. Now, these two terms have x's in them. We want them on one side, and we want the other terms on the other side. So I'm going to do this move. I'll have 2x times log 5 minus x times log 8 will equal, and now I'm going to be adding 3 log 5. So I'll have 3 log 5 plus log 8. You have to make sure you use these parentheses and the distributive property. Now I'm going to pull this x out with the distributive property. X times on the left side 2 times log of 5 minus log 8 will equal 3 log 5 plus log 8. And then this is x times, so I'll divide by its multiplier. X will equal 3 log 5 plus log 8 divided by 2 log 5 minus log 8. This is my exact answer. When I go to grab my calculator and find the nearest thousandth, I'll have a parentheses around my numerator and denominator, and make sure you close log parentheses also. And x will be approximately 6 and 62 thousandths. We want both the exact solution, the nearest thousandth. Well, since this is, now this will be a common natural log, this will be a common log. I'm going to go with a natural log. So I'm going to do the ln of e to the x plus 1 equals the ln of 10 to the x. Now, using my log rules, log base e, what's the exponent I'm raising e2 to get e to the x plus 1? This will be x plus 1 equals the ln of 10 to the x. Use the power rule, the power rule for exponents. So x to the ln of 10 equals x plus 1. I want my x's on one side, so I can make this 1 equals x natural log 10 minus x. Factor the x out of the right side. I'll have ln of 10 minus 1 equals 1. So x ends up equaling 1 divided by ln of 10 minus 1. This is my exact solution, and when I grab my calculator, I found out that that is approximately equal to 768 thousandths. I'm going to combine this into 1e. So, using my rule, it will be adding these exponents. So 5x minus 1 equals 5 to the e. Now, I'm going to take the ln of both sides. So the natural log of e to the 5x minus 1 equals the ln of 5e. Remember, that's that whole thing. This, the ln and the e, that gives me the exponent, equals the ln of 5e. So 5x equals 1 plus the ln of 5e, and x will equal 1 plus ln of 5e divided by 5. That is my exact solution, and find out that x is approximately equal to 722 thousandths. Here's a summary of our strategies for solving exponential equations. If the equation involves a single exponential expression, then use the definition of the logarithm. So change it from the exponential function to the log. And you can usually solve from that. Use the one-on-one properties when applicable. So if a to the m equals a to the n, then those exponents are equal. If it has only exponential expressions with different bases on each side, then take a natural or a common log of each side and use the power rule. A to the m equals b to the n is equivalent to log base a to the m equals log base b to the n, or m times log a and n times log b. Do remember, if the exponent is a longer expression like a binomial 2x plus 1, make sure you put parentheses around it and then use the distributive property, distributing the log to each of the things in the exponents.